Now in this question we have to show that sine of pi by 15 plus sine of 4 pi by 15 minus sine of 11 pi by 15 minus sine of 14 pi by 15 is equal to 0. Now often whenever there are a lot of terms and their addition or subtraction is shown to be 0, then that means there must be some internal cancellation happening. So here we have two positive terms and two negative terms. So we take a chance to check whether positive terms are going to get cancelled with the negative terms. So if you observe the angles, here we have pi by 15 and here we have 14 pi by 15. So therefore if we add both of them, clearly we get 15 pi by 15, which is pi, right? That is 180 degrees. And same thing happens here also. You see 4 pi by 15 plus 11 pi by 15 gives us pi. So that means one of the angles in the pair can be written as pi minus the other angle. So therefore the given expression can be written as sine pi by 15, which we write as it is. So we don't change the first two terms, that is pi by 15 and 4 pi by 15, minus in the third term the 11 pi by 15 can be written as pi minus 4 pi by 15. So that's the change that we are making, minus sine of, in the last term also 14 pi by 15 we are writing it as pi minus pi by 15, right? So therefore we have sine of pi by 15 plus sine of 4 pi by 15, and we have seen the result that sine of pi minus any angle is same as sine of the same angle. So therefore third term is sine of 4 pi by 15, and similarly the last term is sine of pi by 15. So we see that sine pi by 15 gets cancelled and sine 4 pi by 15 also gets cancelled, giving us 0 as required. Let's move on to the next question. Now here we'll see the questions based on the double angle formulae, that is a multiple angle formulae. Here we have to prove that cos 2a upon 1 minus sin 2a is equal to 1 plus tan a upon 1 minus tan a. So let's start off with LHS, that is we have to simplify it. If you observe, LHS has the angles in 2a, whereas RHS has the angle in just a. So that means somehow we have to convert 2a to a, isn't it? So therefore we use the double angle formula. So cos 2a can be written as we have seen, cos square a minus sin square a. If you remember, there are 4 different forms of writing cos 2a, out of which we use the cos square minus sin square. And 1 minus sin 2a can be written as cos a minus sin a the whole square. This might be a little new thing, but if you verify that, like cos a minus sin a the whole square, you see that cos square a plus sin square a will give us 1, and the middle term is minus 2 sin a cos a, that gives us sin 2a, right? So therefore 1 minus sin 2a can be written as cos a minus sin a the whole square. Now if you observe, the numerator can be factorized as cos a plus sin a into cos a minus sin a. It's like a square minus b square is a plus b into a minus b whole divided by cos a minus sin a the whole square. So if you see, one factor of cos a minus sin a gets cancelled, and what remains is cos a plus sin a upon cos a minus sin a. And here if you compare with whatever we have to get in the right hand side, we want tan a, and tan is what? Sin by cos. So clearly here, now if we divide both numerator and denominator by cos, we will get 1 plus tan upon 1 minus tan as required, right? So that proves the result. Okay. Let's see one more sum. Here we have to prove that root of 2 plus root of 2 plus root of 2 plus 2 cos 8 theta is equal to 2 cos theta. So let's start off with LHS. Somehow we have to get rid of all those square roots. So that means we must somehow adjust the square terms inside the roots so that the square roots can be eliminated. Now writing all the roots, and we have to start solving from inside out. So from the innermost term, we can take 2 common, thereby we will have 1 plus cos 8 theta, right? So therefore that further equals 2 plus root of 2 plus root of 2 into. Now if you see, we have the special deduction for 1 plus cos 8 theta, that is 2 cos square half of the angle, that is 4 theta. You see 8 theta will get converted to 4 theta when we use half angle formula, right? So that further equals 2 plus root of 2 plus. Now since this 2 into 2 cos square 4 theta is a perfect square, when we take it outside the square root, we will get 2 cos 4 theta. And basically the procedure will repeat. Now from this term also we can take 2 common, thereby leaving 1 plus cos 4 theta. So that further equals 2 plus root of 2 into 2 cos square 2 theta. That further equals square root of 2 plus 2 cos 2 theta. And lastly we once again take 2 common, and we have 1 plus cos 2 theta, which can be simplified to 2 cos square theta, and taking the square root, finally we get 2 cos theta as required.